people to the boards as much as we need also. But meanwhile, how fun is it to do math and eat at the same time? Go team. Take that with you into college. Study groups are so much more fun when there's food. Okay. Yeah. Let's go through the answers to evens and pause me on any evens where you're like, wait, but I didn't know how to, or I don't know why the answer is. Is that okay? So let's focus on evens first. So number 14, ratio test, just plug and chug. And when you guys take the limit to infinity, did you see that the limit was 0? And so how often will 0 be less than 1? All real numbers. So the radius is infinity. Huh? Yeah. No, you're good. Number 26, if you guys noticed it was a geoseries, you could actually have cheated just a little bit and not done the ratio test. You could have seen the first term was 1, and then your r was ln of x. So you could have just set the common ratio less than 1. No need to test endpoints because it's a geoseries. So it must be less than, not equal to. And then solving between 1 and negative 1, e to the, whoa, 1 over e, what? E to the negative 1. Yeah, rewritten. And then, okay, hold on. Some of you guys were, or at least Maggie, you were saying the sum. If it's a geoseries, plug in your a1 over 1 minus r. So what it meant by the sum, you get to, I think what the AP would say, write the function which is expressed by the series, or write the rational function. It'll give you some sort of hint of taking a series and putting it into a function. It's this idea of either a geoseries that we can take the a1 over 1 minus r, or it should match up with a special Maclaurin in some way, shape, or form. Number 58, oh, that's a big jump. Number 58 was C. You ended up with 2x minus 3 is less than 1 after taking the limit. If you guys notice with the ends, see how they're doing what I was doing? Pulling out the x terms? Or at least not disregarding them, but considering the ends separately, and then you can say, oh yeah, the limit's 1, got it, less than 1, and then solve. The radius of convergence was a half. I think if you guys noticed, they weren't specifically asking you for the interval of convergence yet, because, yeah, in their minds, they hadn't even talked about it yet, because they hadn't covered all the convergence divergence tests yet, so you couldn't have done the full analysis. But I just covered it all at once, because I'm like, well, you know how to test endpoints, I may as well just make it one endeavor card. Does that make sense? Okay. So that's why homework might have felt a little weird, like, why are all of these radiuses? Number 60 was D. Yeah. Was the beginning just this series? Okay. Use telescoping. Oh, we should have known that because it's partial fractions, right? Does that make sense? But why is this partial fraction a little bit nastier than the ones that we're used to? You can, but it's a 3n, so that's a little bit grosser, right? So then, if we were to rewrite this to infinity of 3n minus 1. Okay, how do we do the cover-up method if we have, well, wait, what's the 0? 1/3. So I could plug in 1/3. 1/3 times 3 is 1. 1 plus 2 is 3. 3 over 3 is, oh, well, that wasn't too bad. And what would be the 0 of that guy? Negative 2/3. So negative 2/3 plugged in will be negative 2 minus 1 is negative 3. 3 over negative 3. Yeah. Oh. Why is it telescoping? Do you guys see the positive, negative, positive, negative? So if we were to start expanding it, were they asking for the sum or something like that? Because if it's telescoping, we can find a sum. The sum. Oh, they even tell you telescoping. That's nice. But guys, partial fractions, we should have seen that. In my brain, it's best to start plugging in. I don't know. I mean, there might be another method, but in my brain, telescoping, you're supposed to see it telescope, right? So if I plug in 1, I'm going to end up with 1/2 minus 1/5, right? Plus, and then if I plug in 2, it's going to be 1/5. Oh, that's going to happen pretty quick. Minus 1/8. If I plug in 3, oh, this happens super quick. Minus 1/11. Then if we keep going, 1 over 3n minus 1. Remember telescoping, telescoping, we go to the nth term just for the sake of thinking about, okay, the first term of every new cancels with the prior, right? So then as we keep going, this guy would cancel. So who am I taking the limit of? That guy. As far as seeing whether or not it converges. But it will converge. These are continually decreasing to 0, right?
Wait, how do you think the first one's going to just like...
Looking at a new term, the 1/5 went away first. New term, the 1/8 went away. The first always will go away with the prior terms. You see it? And that's not always the case, which is why I'm careful. But in this one, yeah. So what's left? S is equal to 1/2 minus, technically, the limit as n goes to infinity of 1/3n plus 2, which is just 0. Which, remember, some telescoping, you might have multiple pieces left over. So it's not always just the first term, which is why I write it out. And when I get to the nth term, just for my limit, for my analysis of the function, I just think, when I got a new term, who went away? When I got a new term, who went away? So this new term, when he comes, that will cancel, that will be left, and it'll keep going. Is that okay? Okay, since we're here talking about radiuses of convergence, not getting into testing the endpoints yet, and all the convergence, divergence tests, let's go ahead and talk about odds. So any odds in 10-4, Maggie? 21. Anything else? Odds? Okay. Let's start with 13 then. Simplifying as far as with our limit, because we were doing radius, right? Oh, I should make this big. So what do we got? You should have had x to the n plus 1 all over. Now it starts to get awkward with parentheses, right? n plus 1. Can I do 3 times 3 to the n? Is that okay if I'm doing that? And then x times x to the n? We're okay with exponent rules by now? Isn't it ironic that sometimes we get like super solid in something like exponent rules in CalcBC? Bridget Marquette, if you guys remember from a couple years ago, she's like, I can complete the square now. I did inverse trig for calculus 2 the second time around. Like, she's awesome at completing the square. Algebra 1, algebra 2, pre-cal, calc AB. But now she's like, oh, I'm good. I'm like, oh, took calculus to teach you algebra. Anyway, same thing with exponents, right? Kind of. What's that? Necessity is the mother of invention? That's not quite the perfect phrase, but I think it can kind of be applied. You got to do it, so, oh well, I may as well learn them now. Or maybe your brain is further developed. Anyway, I'm so sorry. We're supposed to be taking the limit. I just think it's ironic how math works. Anyway, kind of in a cool, mind-boggling way. 9 square root of n, 3 to the n, all over x to the n, less than 1. He goes away, he goes away, he goes away, he goes away. Extra stuff. Okay, can't I pull out my x over 3, right? No n's in x, no n's in, and then I have the limit as n goes to infinity. All right, who's left? N square root of n all over n plus 1 square root of n plus 1. Yeah, I was thinking that we could rewrite that to be n to the 3 halves. It's not equal to 1, though. Maybe in my brain I'm doing it too hard. I would have made this guy in my brain. I think I would have made him square root squared so I could put them together, and then made that guy square root squared so I could put it together. Because I can actually join these all under a square root as long as I square root square it. And I would end up with the square root of n cubed all over the square root of n plus 1 squared times n plus 1. Oh, isn't that just n plus 1 cubed? So I guess and ultimately it does end up being the same thing that you were saying. Maybe this just makes it a little bit more clear as to why. But yeah, the degree does end up being tied. So if the degree is tied, because you could pull the square root out of everything, and n cubed over n cubed just equals 1. And so if you have 1, then I can go ahead and say, sweet.
Oh, okay, that's right.
So radius of convergence, because remember, they're not having you test the endpoints yet, which is why I don't like separating them, because you need to know not done, not done, not done. But anyway, the radius is, I think, double check me. Okay, so number 13, got him. Maggie, number 21.
So I got to like the final steps and everything.
Okay, and what'd you get down to?
I got r equals 1 plus pi, but the answer is just r equals 1.
Ooh.
So it's an x plus pi. So I got the limit, and the limit equals 1 times the x plus pi.
Sorry. Should be absolute value. You guys get why the absolute value doesn't need to stay with the ends, right? Because ends are just going to positive infinity, starting at 0, starting at 1. Ends can't be negative. In context, oh, and I wrote an absolute value. That's awkward. Just like the last one, this one, the limit's going to be 1. Degrees are tied. Hold on. So then the radius is going to equal 1 minus pi minus negative 1 minus pi, because you have to subtract pi from both sides. So then 2 minus, no. Whoop. It'd be 1 minus a negative 1, right? And then negative pi plus pi is 0? Is the radius just 1? You were thinking of treating it differently, and you treat it the same. It's like an algebraic expression. Does that make sense? Yeah. Okay. Yeah. Yeah. No. Well. Aryan's saying an alternate way of considering, because I got x by itself because I was thinking interval of convergence, because we've been talking interval of convergence and half the entire interval is the radius. But technically this is a power series centered at pi. And so from pi you go out 1, which is a distance of 2, which has a radius of 1. So Maggie, another way of thinking about it is that you could have just said, how far am I going out from my center? 2, what's half of that? 1. But when you have things like x over 3, we can't do the same analysis because it's not centered at. Just making sure that you don't apply that broader than you should. Is it one of the other sum things? Oh, it's geoseries. Do you see it?
Yeah, I didn't even do the other test. I just said.
Oh, good. Whoa. Yeah. You're thinking the limit, and the limit you can pull out. You're thinking ratio test. But if you're thinking geoseries, remember geoseries is something raised to the n. You multiply that something over the whole something. So the entire thing is my r. Yeah, so you said the whole thing. But when it comes to finding the sum, you have to consider this whole thing as r. So the same way that you said r has to be less than 1, when you go to plugging in anything to the 0 power is 1, 1 minus, the whole thing is r. Oh, this part. Sorry. then it can't go there anyway.
The book said it was -2. See? That's where I was. That's exactly what I got. But the back of the book is -2 and 2. It's like x is in between -2 and 2. And I was like, well, I don't know what I'm doing. But yeah, I had that too.
Yeah. Yeah, I'm thinking absolute value, but the problem, if you square root, here's the absolute value, not there. Oh, no, you're still okay. The 0 and 4 was fine, but when you take the square root, it's a plus or minus square root of 4. So the 0 was okay. It wasn't from here. This is imaginary. You're okay saying that a squared has to be in between. Thanks, Isa. Or Justin, or all of you. When you plus or minus square root it, the absolute value of x, square root of x squared, needs to be less than 4. So x needs to be in between -2 and 2. It was from the 4. There you go. It was from the 4. I'm sure there's a more proper way of writing that. Sorry, guys. I'm more of a discovery experimental, oh yeah, it makes sense kind of person. Sorry. Yeah. So it wasn't from the other. Any other odds on this section 10.4? Okay, so now that we go into 10.5, we're going to have to not just think about radiuses of convergence, not just think about, okay, the distance out from a center that this power series converges, but now actually start stating the interval of convergence, which needs endpoints or boundaries, which needs brackets or parentheses, which means testing at the endpoints, and all of our convergence divergence tests are back. What's the struggle with the test coming on Tuesday then? Am I going to force you to use every single test? No. No. But what are you going to have to be ready with? Whatever test you need for endpoints. Does that make sense? Just something to keep in the back of your mind. So, is ratio test great? It's wonderful. P series, nth term, wonderful, wonderful. But could there be one that needs integral test? Or fill in the blank? Does that make sense? Okay. All right.
I just actually did one.
Oh, sorry, before I... 17?
I think I ended up getting the right answer, but I don't think I did it legally.
What did you do?
Well, so I did the ratio test
Yeah.
with the limit and everything, but then like when I got down to finding the interval convergence, I had like 10 plus 1 times like c that minus 4 over the first one.
What was over? What was it? N plus 1.
10 plus 1 times x minus 4 over n plus 1. Oh, no.
I think it's just n plus 1. Sorry, I did it all in my head, but it's n plus 1 factorial, x minus 4 to the n plus 1. 1x minus 4 comes out. The x minus 4's cancel. The n factorials cancel. The problem is this goes to infinity, and is infinity ever less than 1? So it's... The radius is 0 because there is no interval of convergence.
So it's
Yeah, but if you're answering the radius question, it would be 0, meaning there is no convergence past the point. The point's fine because it matches up like a tangent line would, or like an Euler's method would. But anywhere beyond the point, there's none.
I got that, but I did it totally legally.
What did you do?
X minus 4, then I divided 10 plus 1 over x.
So wait, you would have done this. So wait, what'd you do?
I just, after the stuff canceled out, it was like n plus 1, and then I left the x minus 4 inside. And
Yeah.
I just divided n plus 1, which I substituted for infinity, and then I was like 1 over infinity.
Just be careful substituting for infinity if it's a long answer that you're showing work. Like, I understand what you're doing, and it's mostly right. It's just a bit dangerous as far as your notation. Is that cool? Okay. Let's go ahead and grade evens on 10.5. Wait, who's that guy? 38 is after 60. Do you guys have 38? Oh, I put it all in one. I was so confused. Sorry. Apologies. You guys ended up hopefully with the interval 1/3 to 1, needing to, do you see it? Do you see their work? Check 1, check. Now you don't have to write the word check. I'm just having you say test endpoints 1, 1/3, let's go. Yeah, Maggie. Because in this section, they were teaching absolute versus conditional convergence. You're just needing to see, hey, bracket or parenthesis. That's all we care about. Well, please remember what absolute and conditional convergence is if you're ever asked to state that. But that's not necessary for parenthesis or bracket. So this one is a DNE because we have, well, oh, sorry, 1/3. Yeah, it's a bracket. My bad. It's not absolute convergence, but it's conditional. It's fine. It's fine. Include it. It converges because of the alternator. This one diverges, so bracket parenthesis. Now, in the book, though, it asked about absolute and conditional for B and C. So it only converges absolutely within the interval, not at the endpoints. But conditional convergence is at 1/3. So they're forcing you to analyze it. So technically, Maggie, answering the question, I didn't realize it literally asked for absolute versus conditional. At 1/3, it's not absolute because take away the alternator and it diverges. But the interval of convergence is bracket 1/3, comma 1, unless they say something else. Sorry, how?
I didn't get those as I got 1/3 and then I got it to 2/3. I didn't get 1.
Oh, did you get 3x minus 2 is less than 1, though? Absolute value? So then remember, you just have to take that. Oh, why am I saving? No. Remember, just split it up between 1 and negative 1. No. I think it's the same algebraic mistake you made before. Plus 2 goes on both sides, because you would split them up into 2 separate expressions and solve with good old-fashioned algebra. Plus 2 plus 2. No, just algebra. Just algebra. What you do to one side, you do to them all. Because remember, what this is, maybe some of you guys are just forgetting the inequality. We would have to state this technically if we weren't going to cheat and be lazy. And, sorry, not or. Ugh, inequalities. And. Technically, a sandwiched inequality is 2 statements shortcutted into 1. So we would split it up into, oh, just add 2 divided by 3, add 2 divided by 3. Next one. See the next one? Yeah. Where'd you get stuck, kid? This nastiness? Okay. Okay, so you got an x on top and the other two? Okay, so you got 4 times so the x to the ends are gone, right? And the 4 to the ends are gone. So then you have 1x left. Does that look right? So you can pull out your x over 4, right? Just getting them out of the picture. And then remember, you don't technically have to rewrite everything. You just have to think about, especially, well, I shouldn't say especially, with polynomial expressions, we only have to worry about degree. So if you think about the highest degree term on top, it's an n cubed, right? And highest degree term on the bottom, after I FOIL, after I combine, it's an n cubed on the bottom. Got it. So limit is equal to 1. Got it. Which is why we end up with this guy being less than 1, so x being between negative 4 and 4. Ew. They didn't even write the interval? Anyway, whatever. Between negative 4 and 4. And then testing at both. Testing at both from the beginning, they're doing a limit comparison test. I would totally agree. Because you can think about what would happen. It's a 1 over n. Compared to 1 over n, degrees are tied. Limit is 1. What one does, the other does. So diverge, but this one's an alternator. So therefore, the limit is 0 because the bottom wins and the terms are decreasing. So even though it would naturally diverge, no, it converges. It has an alternator. The absolute value would diverge. It converges, hence the conditional convergence in their answers for A, B, and C. Guys, you can tell they were giving you very specific types of problems because they wanted you to learn absolute and conditional convergence. So. But the technical interval of convergence is bracket -4, comma 4. They just started asking about conditional and absolute. 68 is B. Okay. Simplifying. But you plugged into... Oh, no. Use what we've been doing then, Maggie. Don't worry about what you did last night. Worry about what you can do now. So what will we do now? Yeah. Then what? Yeah, so that would be... No, it's okay. You made the same mistake, but now you got it. Don't stress. But now you got it. It makes sense. If you're doing it one way, you do that in all the problems. In a way, it's less of a... It's less of a danger than someone that's doing something different every single time. It's like, well, do you have a rule in your head? Like, you had it. It was just mixed up in your head. It's okay. What else do we got? Oh, just kidding. Hi, test review. Questions on odds, 10.5. Sorry. Yeah. Oh, they did it gross because they divided everything by 2. I would have just added 5, then divided by 2. So it would be x is... Was that the answer, the multiple choice answer? Ugh. They're just dividing everything by 2. Yeah. Because it would be... Did I still have the picture of it? 2 to 3. Yeah. Sorry, any odds? I didn't mean to leave anyone out. We're okay? Okay. Guys, then what's our objective? We have a test on Tuesday. Should have been Monday. Should have been Monday, but should it have been? Whatever. We got behind. It is what it is. But this chapter has always needed more time. So remind me, how many packets do you have? 2. Theoretically, what's going to be faster, FRQ or multiple choice? Okay, so let's make questions on multiple choice tomorrow. Are you turning it in? No. Should you try it all? Yes. Wouldn't it be nice to have the answers? All right, I'll go ahead and post the answer keys to the multiple choice for tomorrow, to the FRQs over the weekend. Or maybe I'll just post it all at once and trust that you guys are grown up enough to practice on your own first besides just looking at an answer key. Is that cool? Okay. So we'll focus on questions, multiple choice, focus on questions on FRQs on Monday. I don't think I have like an actual book assignment. I guess I could have, but I figured AP practice would be better. But let me go ahead and take question. Justin, was it you? Isa, was it you? Let me double check our homework sheet. Did someone have a question? Oh, you guys are good? Oh. Check out the video. I'll make sure to record for you and or Diva if she's still gone. And like Daniel's been gone. I don't know if is he sick? Okay. But you know what to do. If you have any particular multiple choice, comment on, I'll make sure to cover them. We're looking at BC real quick, the chapter 10 homework sheet. Sorry, I should have finished my word a lot sooner. Oh, that's not helpful. I want the homework page. I honestly don't remember, so I don't want to leave off good review problems if there are good review problems. I think the AP packets are sufficient. Well, now my computer's mad. Yeah. Just AP packets, guys. Does that sound good? So, what's going on, Chapter 10, the test on Tuesday? What's the big Chapter 10 topic? Power series. Section 10.1 was just look at everything geometric, right? And geometric interval of convergence, do I even have to worry about what happened in 10.4, 10.5? No, because absolute value of r needs to be less than 1. So we just need to figure out who is r. Sometimes, and this was the one you were asking about, sometimes we have to look at it creatively to figure out a1, to figure out r's, etc. The geo series, we can think absolute value of r is less than 1. Don't worry about endpoints because r doesn't equal 1 or negative 1. If it says to find the sum is different than a Taylor or Maclaurin polynomial approximation, right? The sum says a whole thing. So it's either telescoping or it's geo. It's one of them. Even if they don't tell us it's geo or telescoping. That was 10.1. 10.2, and we were building power series by like A1 and times. 10.2 started talking about Taylor Maclaurins, right? I think we started building and that kept on going into section 10.3. We didn't really talk about convergence besides memorizing special Maclaurins and being like, oh, this one's all real numbers. We don't know why. Anyway, whatever. Now we know why. We know how to test it with the ratio test, etc. But that was a little bit rough for you guys in lots of ways because not only were Taylor Maclaurins, some of the wording was kind of funny, but also the AP gave you funny clues and Lagrange error came about because if you're doing a polynomial, not the power series, but a polynomial, you're cutting it. And so in nth degree or so many terms, there's going to be error because it's not going to equal. It's only approximating like, well, but way better than a tangent line. So Lagrange came in, but also we had to review alternating series tests because that was also something with just alternating series, just completely disregarding Taylor Maclaurin. We could have tested for error back in chapter 9 OT. Then 10.4, 10.5 brought in the idea of a radius of convergence, ratio test, taking the limit as n goes to infinity, and you guys seem to do well on the homework. So play with multiple choice. I mean, we have like 20 seconds. If you want anything else, if you don't want someone to steal your something else, you want it for lunch, etc. Want to take it to period 5 and continue the Pi Day celebration, spread the joy. Come on up and grab whatever you brought if you want to take it somewhere else. If you want to save something for later. Otherwise, we're done. Pi n? Yeah.
So, just kind of confused, like once you get the endpoint